Cumulative relative frequency plots are also known as ogives. On the AP test, you will only need to know how to read a cumulative relative frequency plot and understand it. Cumulative relative frequency plots are graphs that display cumulative information rather than just showing frequency or relative frequency as shown in bar charts and histograms. Cumulative frequency for a value x displays the total number of values that are less than or equal to x, or they show the frequencies of all groups of smaller observations. Below, I have two histograms of the test scores of 300 students. The graph on the left is a histogram that shows the scores in frequency, and the graph on the right shows the scores in cumulative frequency. The difference between frequency and cumulative frequency is that each lower score is added to the next score, and then this would be added to this. But here, how you read this graph is like you say, okay, 30 students earned a score of 50 on the exam or lower. And notice that only the upper bound of what is put here is in this graph. That's because you know that students in this section got 50 or lower. You don't need that lower bound. So if you read the next bar, you can say 60 students got 60 or lower. You don't need that lower bound because you know that they got lower than 60, and it doesn't matter what specific number they got because it's cumulative. It's anybody who got lower. It's not just between 51 to 60. This is why cumulative graphs are sometimes more helpful, because if you wanted to find out how many students got at least 60 on the exam or lower, you would have to add up both of these bars to find that out. But for this graph, you only read one bar, so that's a little bit easier. So now, let's try transforming this graph into this graph. So what we do is we add this bar to this bar, and then this entire bar to this one, this bar to this bar, and so on. And now this graph should look pretty much identical to this graph. But cumulative frequency plots usually look like this instead, because now the y-axis is in relative frequency, but it's still cumulative, and this graph is just better in general because it makes it easier to read and find exact values. So how you would read this graph is that you can say, okay, 40% of students got 70 on an exam or less. But you can also read it by saying 60% of students got higher than 70 on the exam. Or you can read it from here and say that 70% of students got less than 80 on the exam, and then 30% got higher than 80 on the exam. So that's pretty much how you read a cumulative relative frequency plot.